Hello everyone and welcome to this channel. Today we are reviewing the data behind strategic resources in a frozen frontier. In early 2026, the global resource war transitioned from a boardroom metaphor to a physical frontline reality. With traditional terrestrial mines hitting peak extraction and global supply chains being weaponized as geopolitical leverage, the world is desperately searching for a reset button. For decades, the narrative was that this button was located in the Arctic. We watched the Greenland scramble in real time as receding ice revealed billions of dollars in nickel, cobalt, and copper. But what if I told you that the Arctic was merely a dress rehearsal? The real world, the real new world, is emerging at the bottom of the map. While we have historically treated Antarctica as a frozen sanctuary, a pristine laboratory for penguins and scientists, the physics of a warming planet is literally growing a new continent beneath our feet. A recent study published in Nature Climate Change by geophysicist Erika Lucas has confirmed that by 2300, a chunk of ice-free land the size of Pennsylvania, take roughly around 120,000 square kilometers, will rise from the Southern Ocean. This isn't just about melting ice, it is about the solid Earth itself moving. Today, we are analyzing the geophysical isostatic uplift, the Gondwana mineral connection, and the high-stakes multipolar race to claim a land that technically belongs to no one. So, let's dive into the final frontier of the 21st century. First, we need to dismantle the myth that Antarctica is a static, flat sheet of ice. In reality, it is a continent being physically crushed by its own astronomical weight. The Antarctic ice sheet contains roughly 26.5 million cubic kilometers of ice. That is a weight of over 24 quadrillion tons. To understand the future of this land, we must master the mechanics of glacial isostatic adjustment, or GIA. Think of the Antarctic crust like a heavy person sitting on a memory foam sofa. The weight of the ice compresses the Earth's lithosphere, pushing it down into the semi-fluid mantle. When the ice melts, the person stands up. But the Earth's crust doesn't just snap back. It springs back with agonizing geological slowness. The rate of this rebound is governed by the viscoelasticity of the Earth's mantle. For millions of years, miles-thick ice has been depressing the Antarctic bedrock by hundreds of meters. But as the ice retreats, particularly in West Antarctica, the land will bounce back. Erika Lucas and her team utilized gravity recovery and climate experiment flow-on satellite data to prove a startling anomaly. In parts of the Munson Sea embayment, the land is rising by as much as 40 millimeters per year. This creates a bizarre geological paradox. While the rest of the world is building sea walls to fight rising oceans, parts of Antarctica will experience a relative sea level drop. Because the land is rising faster than the melting ice can raise the water, new islands and massive stretches of ice-free territory are hitting the surface. For a resource-hungry world, these are not just drops, they are future coastal ports for a new industrial age. So, you may now wonder, why is every major power suddenly obsessed with a few thousand square miles of bare freezing rock? The answer is not in our history, but it is in the Earth's. 180 million years ago, Antarctica was the literal heart of the Gondwana supercontinent. It was the tectonic puzzle piece that connected South Africa, Australia, South America, and the Indian subcontinent. This means that the geological DNA of the world's richest mineral zones is mirrored in Antarctica. If you find a massive gold vein in Australian outback or a world-class platinum deposit in the South African bush, those geological trends do not stop at the shoreline. They dive under the Southern Ocean and re-emerge in the Antarctic bedrock. Specifically, we are looking at the defect massif. This is a massive layered mafic intrusion in the Pensacola Mountains. Geologically, it is the twin sister of the Bushveld complex in South Africa. For context, the Bushveld complex currently holds over 75% of the world's known platinum group metals, or PGMs. Here, we are talking about platinum and palladium that are essential for hydrogen fuel cells and high-end electronics. Secondly, iridium and rhodium that are critical for green transition and aerospace hardware. And finally, gold and copper, which we all know as the basic building blocks of our modern economy. These aren't just shiny rocks, these are critical minerals, and they are the backbone of your supercomputer, your EV battery, and every defense satellite currently in the orbit. Presently, the world is dependent on a few specific monopolies for these elements. The emerging ice-free defect massif represents a geopolitical lifeboat. It is the only place on Earth where a massive, untapped supply of PGMs exists outside of the current global power structures. This is where the narrative shifts from pure science to strategic scramble. Because Antarctica is governed by the Antarctic Treaty of 1959, it technically belongs to no one. The treaty explicitly states that no nation can claim sovereignty and no nation can engage in military or commercial mining activities. But like always, there is a grey zone in the fine print. It's easy to agree to disagree over a vault that you don't have a key for. For 70 years, the minerals were buried under 2 miles of moving ice, making them economically irrelevant. But the 2026 study proves that the vault is opening. Look at the Antarctica Peninsula. This is the most contested real estate on the planet. The UK, Argentina, and Chile have overlapping territorial claims that look like a geometric nightmare. Meanwhile, countries like the US, Russia, and China are building research stations at an unprecedented rate. In international law, this is known as effective occupation. While the treaty prevents a formal flag planting, building permanent year-round infrastructure complete with airstrips, 5G towers, and deep water piers is a way of saying, we are here and we will not be leaving. Take China's Chinling Station or Russia's Vostok Station. These are not just weather huts, they are sophisticated hubs located near key geological transition zones. If the ice retreats to reveal a once-in-a-generation platinum deposit, do we honestly believe that a piece of paper signed in 1959 will stop a world that is facing resource collapse? History suggests that When science finds wealth, science gets a military escort. The clock is now ticking towards a very specific date, 2048. This is the year the Madrid Protocol, the part of the treaty that specifically bans mining, comes up for its first major review. Any of the 29 consultative nations can call for a review of the mining ban. By 2048, the technical barriers that once protected Antarctica will be gone. We are already seeing the development of sub-zero autonomous robotics. These machines don't need oxygen, they don't mind negative temperatures, and they can mine 24/7 without a human crew. At the same time, the demand for green energy minerals like lithium and cobalt will be at an all-time high. There is a bitter cosmic irony at play here. The very carbon emissions that are melting the ice and threatening our global climate are the same emissions revealing the minerals we supposedly need to save the climate. We are in a mess around and find out moment for the planet. Antarctica is the only continent on Earth that hasn't been scarred by industrial scale extraction. It is the world's largest wilderness. But as the glacial isostatic adjustment continues to push the land upwards and the Gondwana map reveals its secrets, the temptation of the frozen frontier will become a gravitational pull that no treaty may be able to resist. We are approaching a turning point. Will we have the collective wisdom to keep Antarctica as a sanctuary for future generations? Or will the 21st century gold rush turn the South Pole into the next global battlefield? Let me know in the comments. Do you think the treaty will survive 2048? Or are we heading for the first polar war? Thanks for watching. Stay curious.